What excites me about engineering? I'm thinking.
I've just grown up doing it. Probably like many engineers, watching Star Trek as a kid, seeing Scotty, save the day on many occasions. Like, I want to do that.
I really enjoy designing and creating things. Having all of these tools available to me to create things is just endless amounts of, colors in your palette.
Just the building and designing and figuring out how everything goes together, where it's supposed to be, how it's supposed to work, it lives within me.
Create something that makes people's lives in some way, shape, or form better.
Watching something come from on a piece of paper to something you put in your hand, and just be amazed that it actually works.
For me, engineering brings technology together to make useful products that can benefit people's lives.
This problem-solving thought process that it permeates everything I do, and I think most engineers have a similar story. It was an early experience for them where they realized that they wanted to be a problem solver and or a creator of things that can affect people's lives. And look, it could be weeks, it could be months, it could be years. I think most engineers have an example in their careers when they realize that their job is really not that anymore. Good morning. So I'm going to break character just quickly, and even I have notes. This is an ambitious keynote that we're going to pull off for you guys today. But back to the video. We spent this week talking about stories, everybody's story, and I think that Joe Grant's story for me was, I think, really the classic example. Now he's figured out a way to make hacking a career, but for most of us, we had this drive from a very early age to this compulsion to create, and it can manifest itself in many, many ways. Carl here, Shatke, he's in the electric car business. We have Dave Starkey, who's early on decided that his passion was to design musical instruments, electronic musical instruments specifically, and I think it is a revelation, that first thing that you create. And I think I talked about this last night. It has a soul, and it's emotional. But then you go and get a job, and you realize that the world is at odds with that. And we've spent the week talking to all of you guys, and thank goodness that the slides I prepared actually line up with all the things you guys said. Otherwise, we'd have a real problem. But I just want to talk through some of those trends in the industry. Then we'll show you what we have in store for everybody that will be publicly available quite soon with Altium Designer 20. And then I'm going to bring Leigh, Gawne, our chief software architect, up, and we're going to show you Concord Pro running on Altium 365. Now, as for those trends, this one is no secret. When I first got into the business, I had pivoted out of design. Now, I did design work just briefly, and it was in the audio space. It was power amplifiers for the audiophile market space. And we spent a year designing our next product. A year to design a power amplifier, which isn't exactly rocket science, people. Okay? Then I wanted to be in business. Really, my career aspirations were engineering, but always in this capacity. I always wanted to be in the business end of things. And I got a job, and I was selling Xilinx, FPGA, CPLDs, that sort of stuff. And walked into the office. I remember vividly I had my JCPenney suit that somebody loaned me the money to buy. And I walked in, and they said, well, there's your phone, there's your cubicle, and there's the phone book. Now, don't plan on making any money for 2 years. And I said, well, why is that? And he said, well, because the customer's design cycle on average is 2 years. And quite frankly, 90% of the things that you work on will never see the light of day. I hear some giggles. It's like a death march, right? In any case, this is just accelerating. We had a media luncheon yesterday, and Masha, our new VP of brand advertising, just asked the question, what's on your minds? This was the number one concern. It's just, I don't have time. The pressures are so great. And just kind of put this in perspective, through the arc of my career, we went from a 2-year design cycle to this, which is a survey we performed, and we got good response. So this is very representative, I think scientifically significant, to say that, look, 74% of our customers, all of you guys, design more than 10 in a year. And crazy enough, 42% are designing more than 25 printed circuit boards in a given year. I found that to be quite remarkable. Even though I sort of expected the result, it really is quite profound. And then you put this, just ask them, what's the design cycle? You can see 57% said less than 3 months, from 2 years to 3 months. So this is obviously extraordinary pressure on all of us in this room. Okay? Now, coupled with that is this what we call the rising of the all-purpose engineer. Now, back to my semiconductor days, they were happy to talk to me, okay, as a business person, because proprietary, expensive, long lead time, they were 2-year design cycles, so they needed to know where they would be versus where you are today. And of course, as a salesperson, I wouldn't be doing my job if I didn't say, hey, what about that 3.3 volt regulator? What about 5 volts? And what about all that other stuff that adds up? And they'd say, oh, yeah, you need to talk to Sally, the buyer. And the reality is, that's all on you guys now. Even the humble resistor, you guys are making these decisions, and that's been put on you. The complexity of the designs is increasing rapidly, and what that's forced is 2 things, which is engineers, pure play engineers, are having to assume PCB design responsibilities, and I suspect that, how many of you in the room, by a show of hands, are electrical engineers? Okay, I think that's pretty telling, right? But what that's also forced are the PCB specialists now to become engineers in their own right, because of the data rates, the shrinkage of the packaging, all that stuff, the densities. And again, same survey, if you look at this, 50% have data rates greater than 1 gig. Now, 1 gig 10 years ago was significant. We see designs now 40 gig. 40 gig. It's crazy. I've seen customers with DDR2 memory on a vacuum cleaner. I'm not kidding. I'm not kidding. And with that, only 14% of the people that responded to our survey had the title of PCB designer. And clearly, that's an accurate statistic, at least with regard to this room. But I suspect that it's true. Now, what that now is causing is this. Back in the day when PCB design was a specialty of its own, those people, and also, quite frankly, when fabrication and manufacturing was far more domesticated, if that makes sense. Actually, that's kind of funny, but it makes sense. When we were doing much more domestic fabrication, the closeness between that PCB designer and the manufacturer existed. But as the engineers have taken over and offshoring has occurred, that divide is growing larger and larger and larger. Now, we've been talking about design for manufacture for how many years? It's been in vogue for as long as I've been in the business. Design for manufacture, design for manufacture. I asked a lot of PCB manufacturers that are here this week, the most common response I got when I asked how many of the designs went on hold once they hit your desk, and they said all of them. All of them. And this is a communication issue. How many in the room today have actually visited their manufacturer? What is that, 10, 12% maybe? That's a new thing. That's a new thing. We have a gentleman we hired who started many EMSs, And he went out of his way. He put the design engineers, PCB designers, right next to the manufacturing engineers. And it happened in real time. And we call this now, forget about design for manufacturing. Not that that's not important, but what we want to transform the industry into having is this concept of designing with your manufacturer. Designing with your manufacturer. And doing that in a real-time way. Now, yesterday we talked about Altium's, because of you, Altium's emergence now is solidly the #1 player in this market space. More professional PCB designers in the world use Altium Designer than any other product. And last year, better than 8,000 new Altium Designer family members came on board. That is remarkable. Just remarkable. Now, as we've emerged as this #1 player, it really puts us into this position of having to deal with this thing I call the user imperative. Now, we talked about yesterday that those 8,000 licenses or users that we brought into the family last year, overwhelmingly were done between an individual in our organization and the actual user of the software. This has really been our hallmark, something that really put us on the map. And as I said, initially it was out of necessity. Nobody would take our calls, but you guys would. Right? But when we talk about the organization as a whole, not just the marketing, not just the selling motion, but the entire organization, we are now in a situation where we have more to lose than we do to gain. And if we don't, in a meaningful way, in a big way, pivot and become 100% user-centric, we're in jeopardy. And you will begin to see changes, very, very noticeable changes, and we've already implemented some of these changes, which I'll come back to in just a minute, in the way we engage with you. Our marketing strategy, probably about 18 months ago, we adopted this concept of going where the engineers and customers and users are, and developing events and watering holes where they can come. And AltiumLive is obviously a manifestation of that. So stand by on this. So as we've become, and we're going to bring a couple gentlemen out in just a second, and we'll show you. But as we've become this #1 player, we've absolutely, positively got to maintain our edge. Okay? Our goal was not to be #1. Our goal is to be #1 as a way station to transformation of this industry. And that's what we're going to show you today. We'll start with Altium Designer 20, and we'll show you some of the fit and finish, the spit and polish, and really some of the game-changing capabilities that our world-class development team have put into the products that do nothing but enhance your experience and put separation between the rest of them and us. And with that, if I can welcome Ben Jordan. I think everybody knows this guy. Welcome, Ben.
Thank you.
He's kind of the face, but he's definitely the voice of Altium, I think, if you've watched any of our videos. And I think this guy also needs no introduction, Chris Carlson. So if, out of habit, we call him Carlson. So if I actually slip and call him Carlson, it's this guy. Okay? Now, as we go through this, over here on Ben's side, we'll be highlighting some of the experiences that you're familiar with already in, I'm assuming 19.1, Ben?
This is 19.15.
19.15, okay? And Chris Carlson will be over here running Altium Designer 20. Okay, now, as I said, fit and finish, spit and polish. And if you look at our products, I think, I said this actually a couple of weeks ago, as we were preparing, I just opened the product and said, man, this is really the best looking product in show business. It just really is. And I think that's a testament to the quality of what it is we're producing. Now, these first things I want to show are really kind of around that 750th coat of wax. And what I mean to say by that is, as we established last night, I'm into motorcycles. I'm into building cars, motorcycles, that sort of thing, and I wax them, right? I finish the project, I wax them. And there's probably 750 coats of wax on this particular motorcycle now. And I absolutely, whether it needs it or not, will put a 751st coat of wax on that motorcycle, and it will absolutely look better after that 751st coat of wax. Okay? This first thing we're going to talk through also, I think, is going to be near and dear to many of you, because many of you are long-term users. I talked to a guy who said, I came from PCAT, I went to Proto, the classic story. And this was something that we put into the product, we altered, I should say, when we released version 18 with the new user interface. And the new users loved it. The new guys loved it. But the, dare I say, old guys, the existing user base, the power users like you guys, they give us a little bit of feedback. Ben, what is that feedback? We talk about the properties panel.
It's great. I mean, properties panel in even earlier builds used to be known as the inspector, and it's a very powerful way to edit a whole lot of things at once. I can select, for example, net labels, and I see the common attributes of all those, and I can edit them all together. But if I'm just wanting to, say, add a parameter to a specific component symbol or make one small change to one object, and I double-click on that, it'll open the properties panel. I have it docked on the right-hand side on my screen, and my attention's diverted sideways. It's not a big deal, but sometimes these tiny little things make a difference over time. That up.
Absolutely, Ben. It's 750 coats of wax. I get it. So now, Chris, if you could now show us the enhanced experience that we developed in concert with all these fine folks in Altium Designer 20, please.
Yeah, now you'll remember back in the day before we had the properties panel to alter the parametrics of any object, you'd simply double click on it and you would get a modal dialog. Now, so we brought back all the modal dialogues. There are modal dialogues for each design element, ports, net labels, nets, etc. Show of hands real quick. How many people are glad we brought that back?
Quite a few.
Yeah, that's about what I thought. All right.
I note that there's some extra features in this now too.
Yeah.
It's not the old modal dialog, but we still have some of the enhancements that we brought to the properties panel.
Yeah.
And so we're getting the best of both worlds.
Let's talk about the properties panel in a little more detail. Now, we've done some work here as well based on your feedback. You know, this is all about user experience, your user experience, you know, and when we make major changes and you give us feedback, we do listen. So one of the things that you guys had to say about the properties panel was that when I select an object, I got to click through all of these tabs at the top and find my way around. So where it made sense, we removed as many of these tabs as we could, and we brought those features to the forefront in the general tab. So you'll notice my parameters now, for instance, for a component, are in the forefront. If I go over to the PCB editor, and let's just look at the board properties, we've also added extra information here too. And this isn't just in a couple of places, this is extant across the tool. So as you're using the properties panel, you know, have a look around because you'll see a lot more useful information there. So for instance, under my board information, we've got the board size, which has been around for a while. But I have the area of the board, the component area, and the density. So we use the courtyard of the component to actually figure out how much of that board is being covered by components. Component density is often something that's going to, you know, drive your ability to properly place a board and have routing channels available. And so this is just one example. You know, as you're using 80/20, look around and notice that extra information that we're providing you now.
So Chris, on that note, just as another subtlety, which actually sets us up for future development work, but something we've added on the schematic editor, yeah?
DirectX?
Correct. Yeah.
The schematic editor has been refactored now, and we actually support DirectX now both in the schematic editor as well as the PCB editor. This is going to make for a more seamless experience, a quicker experience, and it gives us the platform and structure we need moving forward to bring in a whole bunch of new features and functionality that we're looking at.
Thank you, Chris. So this next topic, and we're going to build to the crescendo, as it were. is near and dear to my heart because it was something that I was really heavily involved in as a young guy here at Altium, selling the product, then marketing the product, and that's this concept of the unified design environment. This is something we absolutely brought to the industry. It absolutely, to this day, is still quoted as one of the things that our users love and new users absolutely aspire to have. But we've backed away from it from a public-facing standpoint, mostly because I think maybe we just felt that we had grown tired of saying it. But the reality is the user base didn't. They love it. The second piece of it is our competitors, as we really emerged, they kind of appropriated the message. And I say that's unified in name only, right? As we came up with the word unified because it's one. It's much different than an integrated suite. So first of all, I'll say we're bringing it back and we're taking it back. Unified design is our thing and absolutely something we're going to continue to focus on. And on that note, what we're doing now in Altium Designer 20 is adding a bit of dynamic nature to the unified environment. So if Ben, you could talk us through the existing experience in Altium Designer 19.
Okay, so many of you will note that when you look at an object, and a lot of this comes down to components as well, we have the properties of the component, as we've been discussing. The component's not just a symbol, it's the whole package, it's the 3D model, etc. But for the overall design, if I go and make changes in schematic, every time I want to make a change, I have to basically recompile the project. So I'm going to go ahead and do that. Now that doesn't take too long. And we actually, in 18 and 19, made great improvements to the speed of that. Yeah. But it's something, it's just one more step that every time I make a change and want to see that in the flattened hierarchy or cross probe or explore using the navigator panel, I have to compile every time and do that before I move anything to the PCB editor, like net color highlighting or any of those things. Sure.
Yeah, it's not a huge thing, but we've definitely made this experience better, certainly more efficient. And Chris, if you want to just kind of show us what the new dynamic unified environment looks like.
Classically, or historically, compiling your project does four things. It instantiates net connectivity throughout all of the schematic sheets in your design. It instantiates the hierarchy of the design. It builds the unified data model in the background and runs an electrical rule check. Now the first three things here, instantiating net connectivity, instantiating hierarchy, and building the data model have all been automated. This now happens real time. So here I've got a blank project and we're looking at the navigator. I can see my schematics up here. But as I pull components into my design and drop them, that is dynamically being compiled. The net connectivity is instantiated, the hierarchy is instantiated, and real time the data model is being built for me in the background. Now, let's go to the projects panel, and I'm actually going to drop a device sheet in here. And you'll see that the hierarchy just automatically builds. All right, so there's no more compiling your design. Now, in this particular build, this is an early beta build that I'm using, you'll notice that the compile project option is still there. However, today, all that does is run an electrical rule check, and I've been assured by a couple of the developers that by the time we have a release candidate, they will name that something appropriate.
So on that note, we talk about our development team, Chris. Absolutely, positively, our competitive advantage. The speed and volume of things that these guys are capable of creating and the way they can react, I think is second to none. And it is the envy of the industry, in my humble opinion. And now when we talk about Altium Designer 20, what they've cooked up in regards to interactive routing is absolutely, in my opinion, the star of the show. And I suspect that it is one of the areas where you guys absolutely spend the most of your time. I actually know that because I surveyed you guys and you responded. And we'd like to walk you through that now. But, Ben, if you could, talk about, are there any board designs today that we're not capable of producing?
No.
No, of course not. So, I mean, like, as an example, what have you seen?
Backplanes, Ethernet, and obviously, computer motherboards and things. We're running with running signals now. People are designing with anything that's 28 gigabits per second is common, and of course you're dealing with harmonics of that. So anything up to and above 100 gigahertz bandwidth is required.
Sure. What about density?
And density, same thing. We actually have some reference designs that we've actually had done by some contractors that are really impressive, doing many layers. HDI, VN pad, there's really nothing you can't do. And a big part of that, making that possible, is some of the changes we've been working on with the layer stack and so on. Yep.
It's an excellent point. We're going to come back to that, this development arc, which we'll talk about. But for right now, if you could, Ben, talk about and show us a little bit about the current experience when we talk about, in this case, escape routing on obviously a very large fine-pitch BGA package.
Right. So obviously, this is a contrived, strange-looking net, but it's to illustrate some of the changes where we've had developed by our ACE routing R&D team here. I'm actually just going to delete a portion of this to show you the escaping. And this is the current experience in 19. It's pretty good. It was better than 18, and that was better than 17, and so on. But you can see I can go out straight, but if I have to go around a few objects, I'm going to be taking my time and clicking here and there.
But all 4590, yeah?
It's all 4590. Any angle's kind of out of the question at this point.
Says who?
For this.
Chris.
All right.
Show us any angle routing.
All right. We've done a lot of work in, as Lawrence points out, any angle routing, as well as routing with cornered topologies. So here in my cornering style, I'm going to choose any angle, and my hugging style is going to be rounded.
So just wait a second, Chris. That's in the properties panel?
That's in the properties panel.
That's a new thing. I haven't seen that before.
Ah, okay. Now, we've also added, and we're going to be showing you this momentarily, some new push features, as well as some enhancements to the router. As you're routing, you guys probably know by now, if you hit the tab key, you'll freeze the workspace, and the controls will pop up in the properties panel. Same thing for the new push features, so look for that, okay? All right, now, wouldn't it be cool if I could just sort of snake that route right around through there and have nice, smooth transitions? Now, this is pretty cool. However, check this out. As I'm routing, this will route tangentially to my clearance rule all the way through there. It will use arcs and tracks where necessary, and it's calculating all of that on the fly.
That looks really cool, but how do you edit that after the fact?
Well, we've got something up here that's pretty cool. It's actually, Ben, I'd like to see you give a go at editing that track up there, and let's see what your experience is.
So this
I'll
is
show you mine.
Yeah, let me introduce. That's why we call him Carlson. So, Ben, if you could show us the existing experience, I think we just go ahead and transition right into the new sliding capabilities that are put into Altium Designer. But show us the existing experience.
Now, I emphasize editing existing routes because a lot of time is spent doing that exact thing. In this situation, in the real world, if I had tons of room around it, I would just reroute it, of course, as would you. But this is important to illustrate what happens today. It's kind of difficult to grab something. We still maintain a lot of the angles and things, but it's going to work, but it takes me more mouse clicks, really. That's how it goes. And so I would probably end up just deleting this whole thing and starting again. It's even similar if I'm down in a slightly more dense area, or if I have something like this differential pair and I want to change the length here slightly to make room to put in a via or some other routing, I can push that, and it's not going to treat the whole thing as a pair, and I may lose
You lose some coupling there,
coupling,
right?
and it's just it requires a little more effort,
A little
and
more finesse,
more
yeah.
clicks, more time. It all adds up.
So now, Chris, if you could just show us now all these new sliding features, and I would say just roll right into
You got
length
it.
tuning.
Yeah.
And show us what we got now in Altium Designer 20.
All right, let me show you what I got. Now, this was obviously very chaotically routed with the any angle routing. Now, as I'm moving this track along, I'm going to freeze the workspace. It's using these adjacent tracks as like sliders. So it's going to slide along those, and then when it comes to a vertex, it's going to try to transition to the next adjacent track to use that as a slider as well. So notice as I come up here, we get to this discontinuity, and then this one, and we just slide right along there.
Oh.
You like that? All right.
I'm very pleased that you clapped.
And we're recording this for the R&D team. They put a lot of work into this.
They really did, yeah. They're quite proud of this, and they should be.
All right. Now, as I'm routing along and pushing things,
Ooh.
how do you feel about that?
Now you're showing me yours.
All right. Let's go to an inner layer here for a minute. Let's go back over to this diff pair that Ben was trying to drag here. I'm just going to grab that and drag it.
Ooh.
Okay, now, again, I mentioned that the sliding, pushing features also have their controls. So you'll notice that this switched from 45s to arcs, right? Well, if I hit the tab key, I've got some other controls over here. I've got my 45-degree rounded or mixed, and it will transition where it makes sense. This is also where I have what we've classically called routing conflict resolution modes, our hug and push and all of that. Those features have now been added to the push capabilities with these sliding features. All right, let's,
What about length tuning, Chris?
yeah, well, hold on, I got one more of these that I think is
got one more?
pretty cool.
Okay.
Yeah.
This is cool.
I gave him permission to go off script.
You
'cause
did.
He's so passionate about this
All
subject.
right, so I want this rounded. Notice I can push things with, and I can have them push with 45 or rounded, right? I'm going to select a couple of these. How do you feel about that? All right. So we've also done a lot of work on length tuning. And there's more to come, but we've really taken this to a much higher level. I'm just going to give myself a little room in here. Now, all right, so I'm just going to put a little bit of length tuning in here to begin with.
That's
Now,
insanely fast.
you noticed that, did you?
Completely extemporaneous.
Now, Ben, how would you go about altering the shape or amplitude of that in 8019?
So in 19, I would have to, I think these have all been exploded to primitives, so let me just add another tuned segment here, if I can. So there's a tuning segment, and it creates a polygon. I'm stuck at that perpendicular to where I started. So if I want to change the angle of that, I can't really do it. I can add more segments by dragging bits around, and I can change the amplitude. I can do all of those things and extend this around the trace. I'd have to add some some vertices, and that's cool. Like, it is actually really nice. I like that. It's just a bit slow, and it's fiddly. It's fiddly at times. So,
Yeah, what do we got
All
now,
right.
Chris?
All right, so the handles still work. I can still drag these handles around and resize this, but how would you like to just kind of move it up there? Or drag it down, maybe put it down here, and so on. Just move it around, drag it around, where have you.
that's just so cool.
It is really, yeah.
It is, isn't it?
Yeah. Genuinely, I get impressed by it every time I've seen it. All right, so last year's ooh and ah moment when we showed y'all 19 on this very stage, for my money, it was this layer stack manager. However, what we didn't do, or I should say I didn't do a good job of really explaining in context what that meant. So I think it was even a subtle mention that the new layer stack manager had some field solving technologies in it. And that was based upon a relationship that we engaged in with an organization or a company called Symbian. And if Ben, maybe you want to talk about what the significance of that was in 19 with this layer stack manager, which, by the way, got great feedback from everybody. But if you could just kind of walk through it, and then we'll put it in context with where we're going.
Yeah, there was a lot added in there, and of course, better support for printed materials, HDI back drilling, all of that. But the real day-to-day, everybody benefits from this feature is that field solver technology that gives you very, very accurate impedance profiles that you can then leverage in design rules. So it'll automatically set your trace and space, and as you change down through the layers, it'll set your gaps for differential pairs and so on. And that's cool, but something that's very easy to go unnoticed because it's just subtly shown here in the properties, when I select a particular impedance profile, it's actually also giving me the propagation delay in nanoseconds per meter, or if you switch to imperial, it'll give you, I think, picoseconds per inch or whatever it is. I'm in metric right now. It gives me the series inductance and capacitance per unit length, and that is really useful. So what if I need to length tune?
Yeah, in practicality, in application, right?
So that means for each impedance profile down through the layer stack, I don't have to use an external calculator or solver, and this is very accurate, but I do still have to figure out what are my actual length tolerances by length.
And so this is what we didn't explain, was this was by design. This was put in place as a beachhead for the things that we would be including. And for me, this next capability is really about time. And that's tune for delay. That didn't get one laugh. So Chris, if you want to show us tune for delay.
Sure. All right. In my design rules, for my length, my match net length, anywhere where I'm actually basically length tuning, adding serpentines and so on, I can tune to length in terms of units or in terms of time. And this is actually coming back from the data from the solver in the layer stack manager, so that when I'm length tuning, it's actually calculating what that needs to be to give me the right tune for delay. Now, along with this, we added another new rule. It's called return path. For my return path profile, I can choose one of my impedance profiles that I've defined in the layer stack manager. But what this rule is going to do is make sure that my signal is tightly coupled to the copper pore or plane layer that its impedance profile was calculated to. So if I cross over a gap in a plane or from one polygon to another, via thermals, any gap in that reference plane for the impedance of that signal, I'm going to get an error. Now, there's a couple of settings here. One is the minimum gap to the return path, but then there's this also exclude pad via voids. That's basically there to exclude the first pad via void. So as you're routing out, obviously this track, there's going to be a punch through from the via that it's being routed from through the plane or polygon that it's referenced to. So basically that's there to exclude that erroneous error that you would get.
All right, thank you, Chris. So I'm going to go ahead and ask the...
Come on, let's hear it.
It is
That's
about
actually
time.
amazing.
It is about time. I tried it again, you still didn't laugh. Now you laugh. At my expense. With that, I'm going to go ahead and ask the gentleman to leave. And I'm just going to step through a couple of the things we didn't show, and then we'll bring out Leigh Gawne in just a second. So if you could cue the slides, thank you. Thank you, Chris.
You bet.
Well done. All right, so that's not all. So this is just a block diagram that shows the functional areas of enhancements and capability additions that we've added in Altium Designer 20. And I'll just kind of give you a bit of color commentary around them. New Spice engine. So in the context of analysis, we've added a new Spice engine. The immediate result or experience that you'll have is that every model you throw at it now should work. There are some future developments that we're undertaking now that will add a lot of richness to this experience. But for right now, go ahead and throw your models in there and you should see a marked improvement in our ability to accept them and use them. Interestingly enough, I didn't show creepage. There's a new creepage rule, but this gentleman who's here in the audience had come by the office just to visit with us, a guy named Dugan, and he asked me, well, what's coming in 20? And I said, well, this, that, and anything. And I said, the first guy I told about it was, I said, well, you do any high voltage? He's like, that's exactly what I do. So he was very excited about this creepage rule capability. Return path, Chris showed. Multi-board improvements, that's another area where we are just the leaders. And in this next publicly available version of Altium Designer, ActiveBomb will now support the entire project, so every board in the project, as well as we've enhanced the 3D PDF to support the multi-board project capability, as well as now enhancements to the library migration, which will make good sense when we talk about 365 and Concord Pro specifically running on Altium 365 in just a second. Now, this is a topic that we talk about publicly. And I feel like, look, you guys call them bugs, why shouldn't we call them anything else? Bug's a bug. And as Rocky once said, it's not how hard you hit, it's how hard you can get hit and still get up. So this is an area where, again, I think we have a huge advantage with the development team that we have. And look, you guys tell us this, right? What's valuable about owning subscription with Altium? And 67% number one answer said it was obviously this ability to bug fixes. Now, as we talk about Altium 365, there's some additional value coming in your subscription as a product. But when we look at this release and the history of releases since 18, which is this new user interface, which gave us enhanced capability in tracking such things, what you see on the top, this squiggly line, are the unique users affected, or their life was improved directly per votes on Bug Crunch. And you can see clearly that we're making significant efforts. Now, by no means would this be something, hey, we fixed this problem, and we go on about our day. As I said, this user-centric, this user imperative that we have will be felt very much in this department. So in this release, I've got 108 here, but it should be anywhere between 108 and 120 individual bugs crunched coming in Altium Designer 20. But stand by, this is an area where we're going to invest heavily. And also just closing the loop with you guys, engaging with you where you do business, virtually and physically. Okay. Now, what I'd like to do now is bring up Leigh Gawne. So Leigh, if you were here last year, you may have remembered Leigh Gawne.
Hello, AltiumLive. Good to be back again.
So
good to see you all.
So Leigh is a gentleman that we came to Altium through acquisition. So we bought his company, Siva. And it's funny, as things go, the older you get, the faster time goes. I said, well, you've been here about 18 months. He says, no, 4 years. So that...
Time flies, doesn't it?
Yeah, I don't know how I felt about that, Leigh. But so Leigh has just recently been named our Chief Software Architect. So congratulations to Leigh. I'm very excited about it.
Thank you. It's very kind.
And Leigh, on this stage last year, what have you been doing since this stage last year, Leigh?
So yeah, last year at this very event, we introduced Altium 365. And the last year, we've really been working very hard behind the scenes, okay, to continue to evolve that platform, to gain maturity on it, and really make sure it's ready for prime time, okay? Obviously, there's many challenges behind ensuring that, that platform has high availability, it's scalable, it's robust, and it is secure. So the last year, we've been really focused on ensuring that we keep things simple, convenient, and they just work. And that's really what we talked about a lot last year. To that point, the user experience from the very first engagement with the platform through to everyday use has been constantly under the spotlight. So that's really where we've been. So this year's been
I know you've been
a
busy,
long year.
But actually, I think it's probably worthwhile, Leigh, if you just explained again what Altium 365
What Altium 365 is. Yeah, sure. Altium 365 is our cloud platform, okay? Its purpose is to make things easy for you, all right? By simplifying collaboration between all of the stakeholders in the value chain of electronics design and realization. The long-term vision is to connect design, manufacture, and supply chain in a way that really transforms the experience of designing and realizing electronics today. Now, being a platform, applications are designed to run on top of that platform, and Concord Pro is the first application that we're going to show you today that runs on that.
Did you say Nexus Server?
Sorry, I don't know what you're talking about there, Lawrence.
Clearly, I don't either. So, Leigh, Concord Pro running on Nexus, excuse me, no, I've done it. Altium 365. What's the current status? What's the current state of play?
Well, let's first of all talk about Concord Pro and just say, what is Concord Pro as an application? So, Concord Pro is a design data management application with a specific focus on component library management and the ECAD, MCAD inter-exchange, shall we say, okay, or interconnect. Concord Pro can be run on the Altium 365 platform, as I just described, okay? It just works out of the box, okay? That's a really important thing. Or you can purchase it and run it on your own infrastructure, on-prem, if you wanted to.
Anybody using it today?
Second?
Is anybody using it today?
Yeah. I mean, let's look at the state of play of where we are today. So we had a closed beta program, and that's now come to an end. And I'm really pleased to say that Altium 365 now has general availability. So as of end of last month, we are open for business, okay? So a really big milestone for us. So today I want to share with you, okay, the experience of one of our beta customers, Skyships Automotive, who has adopted Altium 365 platform. They've been on it for about 15 months now. I really want to show you what they've managed to achieve with what we have today. So let's cue that Skyships video, please.
A supercar is something that's been on your wall in your childhood dreams. So when you get it, it's your pride and joy. It has to be perfect. You will cherish it, and you'll polish it, and you'll look after it, and that makes them special. Our products have to supersede all expectations and be better than anything else that they could buy. We are a Tier 1 automotive manufacturer, so we supply the automotive industry with electronics, specializing in infotainment systems and digital clusters, and we are responsible for everything from the design, the manufacture of the hardware, all the software and the graphics, to what the user experience is when you buy your car. Infotainment systems, pretty much everything that you would find in a screen today, connecting your Apple CarPlay, connecting your phones, Android Auto, your Bluetooth, making calls, the comfort features of the car when it's too hot, and these days the display that tells you how fast you're going or if there's a safety warning, and that encompasses what people describe as infotainment.
What gets me excited about the design process is the ability to see my designs in the real world, seeing them going down the road in cars. We spend a lot of time collaborating with different groups of engineers, customers, mechanical engineers, software engineers, and all of them want to see what we're doing in the way of schematics and PCB layout. So this is where Altium 365 comes in very handy. We use the Altium 365 workspaces as a way to keep all our components and designs and projects all in one place so that everybody's working from the same source of information. It's also useful for keeping track of those parts as well, and we find the version control system in that very useful. We can look around the board, identify components, test points, nets, all the things that we need to find when you're out in the lab probing around and testing. Altium 365 has allowed us to transfer the information to manufacturing in a clearer way so they can see precisely where all the components are supposed to be and the orientation for them.
When we receive the design from engineering, having Altium 365, it allows our production team to actually go on the web using Altium 365, and we can review the data up front before we commit to doing a design. The ability to add comments has tightened up that feedback loop between production and design. So when we are doing a first off, we can check component heights in 3D before we commit any board to going through a reflow oven. It's great because we can also check beforehand as well as when the board is actually being built. So if we suspect there's going to be any component clashes, we can adjust for that in our process. If you're at a party, you're always introduced as, oh, this is the guy that works on this car. And they all go, oh wow. It's a little bit overwhelming sometimes, but it's a nice feeling.
I've always designed things, I've always made things work, right from early days in school. I was the one that was making things when everybody else was doing proper work.
We found that production and design are working better together. We are now able to design faster using different teams at our different locations. We had invested heavily as a company in our production equipment and software, and our ECAD design department was lagging behind and had become disconnected. The cloud systems and increased collaboration offered by Altium was the way forward for us and has helped us increase our productivity and the link between design and production, and that's why we chose Altium.
Can you hear me now? We'll try and get through. Is that better? I think. This moment in time. There we go. Apologies about this. Just be a couple secs. We good? We good? Is that good? Hopefully that's the first and only glitch for this mission, because today. No, perhaps not then. Looks like two glitches. I was behind the stage, you know, I had so many things to remember and do today. I just thought this was going to be. Anyway.
These devices weren't designed, you know, using Altium.
No, this is something else. Are we good? Right, we good? Don't worry about it. Right, we're good. Hopefully, can I jump around? Yep, perfect.
Awesome.
All right, awesome. Thank you. All right, appreciate your patience. Right. So today we've got a little bit of a show for you where we're going to demo the power of capabilities of Altium 365 and Concord Pro as they exist for you today, okay? So everything you're going to be seeing, you're going to be able to do. It's all running on our production environment, okay? Now for the purposes of this demo, we have one really ambitious customer who loves to push the limits, and he has asked us if we can complete a design for him from scratch, including an enclosure, in 45 minutes, okay? Yes, this is slightly crazy, but with the support of my wingman and design guru, Mr. Ben Jordan, and various other collaborators that you'll see come on in one moment, leveraging the power of Altium 365 and Concord Pro, we might just be in with a chance to do this, all right? So bear with us. Everything you're about to see here is going to be done live, okay? There's nothing pre-recorded, and there is absolutely no safety net beneath the tightrope. Unlike a dangerous magic trick, I do encourage you, please do try this at home, all right? And in the office, and anywhere else that may be convenient, all right? So on that, we're going to get started with our demo. So first of all, we're going to get set up with Concord Pro. I'll walk you through what this experience is going to be like literally from the beginning. So if you've never seen it before, when you go to altium.com/Concord, you're going to be presented with this website that you see up here, okay? Then on the top right-hand side, you're going to see this button, Try Concord Pro. Just go ahead and give it a click. And you're going to have this dialog box pop up where it's going to ask you a few details. Your name, so Ben's got an account here. If you didn't have one, you could just easily sign up for one with AltiumLive. I'm going to click through this, and it's going to ask you a couple of questions. All right, it's going to ask you your location, because what's important is that we provision a workspace and it needs to be in a geographical location that's closest to where you are for your best performance, okay, or best performance of the system. So go ahead, answer a couple of questions, click on Please Wait. It's going to take you through. Basically, you're then going to get an email, okay? Ben will show you that. And this is when we provision your workspace. You'll get this saying that we're taking care of it behind the scenes. You'll then get another email a bit later with a link in, and a few moments later when we provision the workspace, and that's what you click on that's going to take you directly into that workspace, okay? There's also another way of doing that, which is through the AltiumLive dashboard, which is what you're seeing right now. So Ben's going to click on the dashboard, click on Workspaces, and it's going to be taken directly through to that Concord Pro workspace running on Altium 365. Okay, so when you get into the workspace, this is what you're going to see. All right, we've got this lovely homepage with a bunch of videos and other material on there that is going to take you through Concord Pro. It's going to explain to you all the kind of capabilities that it has. You can watch these videos to really get an understanding of what it can do. There's also a step-by-step guide, which is what Ben's showing you now, which allows you to, step-by-step through screenshots and text actually understand exactly how to do certain things within Concord Pro. So a really helpful resource on the homepage for you. So what we're going to do now is go back into that workspace somehow.
Give me 1 second while I log back in.
This is the security here aspect.
Okay.
So we're into the workspace. All right, perfect. So what we're going to do, if you just click on the team button. So as part of today's demo, we're going to have a bunch of collaborators, okay, that are going to come and join us. So the first thing we're going to do is actually set up our team. We're going to get some of those collaborators come into the workspace. So at this point, Ben's hit the button. We've got this dialog pop up, and what we can do is invite members to come and join us and come and work with us. Now, as we type their email addresses, anyone who's part of your organization, and obviously us being Altium, is going to automatically prompt you with their email. So you don't have to remember their full email. And I mean, you can also invite people from outside of your organization as well. You would just literally put the full email address in here. But it's then going to warn you that you've got someone outside your organization who you're inviting to come in and collaborate. So it's kind of a security thing there just to make you aware. You can also add roles to these guys. We're going to make them administrators today, but you can also define different roles inside Concord Pro, things like mechanical engineering role or librarian role, these kind of things, where you can control security access and all this kind of good stuff. So once we go ahead, send this invite, all of these collaborators are going to get an invitation to the workspace via email. So they'll be able to click on that link in the email that they get, and they'll also have access to the workspace in the way that we're seeing it now. They'll also be able to go to the web browser and see everything that they've been unable to essentially see. All right, so it's very straightforward to kind of get the workspace provisioned, get your team set up, and get everything up and running as the first step. So as the next step, what we're going to show is connecting Concord Pro to Altium Designer. So how do we actually do that? Well, with Altium Designer 19 and the upcoming 20, it's actually really, really easy. What you've got in the top right-hand side is a drop-down menu. Okay, so once you're signed into AltiumLive, you'll actually get a list of workspaces that you can connect to. And in this particular case, Ben's got a few workspaces. We're going to actually choose the AltiumLive Demo 2019 workspace, which is the one that we're working with today. So once we've clicked on that, you will also see when we're connected, in the top right-hand side, it shows that you're connected to that workspace. So Concord Pro and 365 as an infrastructure and an application have been kind of really deeply integrated into Altium Designer to make it really straightforward and really simple to use. Okay, so as a next step today, I told you we're going to actually design a board from scratch. So what we're going to do now is actually start by creating a project. And this is very similar to the way that you guys would be used to doing it anyway. The location in the top left is shown as AltiumLive Demo 2019, when they're going to give the project define some project information, project name, project description, and the project type today is actually called USB stick. So this is actually using a feature called templates, where we can essentially have predefined schematics and layout that we would use to essentially create our project from. So from a schematic point of view, for instance, we would have our own kind of like logo in the bottom of the schematic, our own kind of page size, and other things like grid size, all that kind of stuff in the schematic. So that's a really useful feature. So now we've created that project, one other thing I should say is that this particular project that we've created is using Altium 365's formal versioning control. And that basically means 365 has an integrated Git server. So here we've actually created the project using that version control service. Now you don't have to use that. If you've already got version control that you're using, which is external, which is to you, you can also go ahead and do that. So we support that. 365, it's not a case of everything or nothing. You can choose what you do and don't use with it. So at this point, we've got the project. You'll see that there's some blue kind of crosses next to it. That means the project's been created, but it hasn't actually been committed and pushed up to the server as of yet. So that's exactly what Ben's just doing by right-clicking and selecting the Save to Server. So then just putting a comment in, and as you can see, this whole thing's just getting pushed up now to 365. Very simple, very straightforward. Okay, so the next thing we're going to do, we're going to switch back to the web view. And if we click on the Projects tab, you're going to see the project that we've just defined appear. Okay, so that's the USB auth key project. And we've got these nice 3D thumbnails when the page loads, so you can easily identify your project, and you can see that's the one that Ben just created. So now at this point, what we're going to do is we're going to invite our collaborators to come along and collaborate on this project. So we click the Share button through the ellipsis, and while you could share it with specific people via names or emails, what we're going to do today is just say everyone in the team is going to be able to write. So everyone we've just invited to collaborate is going to have access to this project. Just a case of clicking share, then you're done. And of course, we can change all of those visibility and accessibility options as and when we like through the same dialogue. Okay, so it's that simple. So 2 steps, getting it all set up, getting everyone in the workspace. Second step, getting your project set up, getting everyone ready to collaborate, and we are pretty much ready to go in only a few moments. It takes no time at all. Okay, so the next bit we're going to move on to is the schematic capture and manage components part of this to show you a bit about how that whole thing works. Okay, so what Ben's going to do is he's going to get on with capturing the schematic, the logical part of the design. And in the meantime, what we're going to do is I'm going to invite Christian, who is our librarian, who is going to connect in remotely and is connected to our workspace via Concord Pro, to come and join us. And what he's going to do is he's going to create a couple of components for Ben in parallel while Ben is actually doing this design. So could we cue Christian, please? Hello, Christian. How are you doing?
Good evening, and grüß Gott from Germany. Ben asked me to go for some components, one easy and a little bit more complicated component. To show you what I do, I will share my screen. You should see my Altium Designer right now. And as Ben is quite fast in doing these schematic things, I have to be fast in creating the components as well. The first one will be a resistor. I already know this will be a resistor. It will be in a SMD housing. So I will narrow down the search a little bit at least. Unfortunately, it's over 800,000 components that I do find here. So I'm interested, not in all those components, but 220 ohms, 5% of tolerance, and 0402 housing. The search has been narrowed down to 44 components, still some too much for me. I'd like to stay with components that are RoHS compliant. I only want to see components that I can get as well. So I'd like to have only components that do have stock. And I'm interested only in components that do have a symbol and footprints for Altium Designer included. So I come to 9 components which are fitting to these needs. And if I don't exactly know where the differences between those components are, I can select a second one, and in the lower part of the manufacturer part search panel, I can see where those components are identical and where not. I'd like to stay with the first component, and I only have to say I'd like to acquire the thing. Of course, I have to tell our Concord Pro what type of component I'm importing. Yes, it's a resistor, but we could name it differently. In Germany, for example, Widerstand or something like this. This cannot be known by the tool automatically, so I have to choose it. He will right now acquire all the data, and we can see that some work has already been done. He's still getting some footprints, and if everything is done, I can see the component does have a name, which I could change. There's a description. There are these parameters, most of them driven from my component template, but there are some additional parameters that I could delete if I want to. Even a data sheet has been acquired. I got the manufacturer information, so who's manufacturing the thing, what's the manufacturing part number, where could I get those components for? And I got as well some footprints following IPC norms, medium, narrow, large, all work done. Well, one thing I'd like to change, which is not that ideal for me, with my resistor, I'd like to see the value when I place this guy. So I will save this, go back for my component, and this looks good. So right now I can save everything to the server, and he will ask me for a release note. Usually this is my first release. So first release of a component with Concord Pro, which is of course not true, we did it before, but okay, usually you would write something different like first release, second release, why did we do a second release, because of this and that change. He's right now pushing all information over the Atlantic to the American server, which should not need too long. And if my screen is cleaned up, which is right now the case, I can see no messages, which is good, because only errors get shown there usually, and I can go on with my second component. This one will be a little bit more complicated, as I do not find all data in my manufacturer part search, so I will go with a File, New, Components menu to create a component myself. Of course, again, I have to tell the system what type of component I'd like to go for. It's a memory device, integrated circuit. I do get different parameters by default. And here I get some help from Octopart as well. And Ben has been quite precise what component he wants to see. It's this encrypted memory device he wants to see. And astonishingly, I got some additional data, again, from Octopart. Not the symbols, not the footprints, but all the parameters, including a data sheet. And inside this data sheet, I would find, of course, information about the symbol, information about the footprint that I have to create. And I can create right now a new symbol manually, completely manually. Obviously, I don't have an existing one. I will use the symbol wizard to create this. And have a view, he's creating 8 pins for me. This number is taken, I will not close it, this number is taken automatically from the number of pins that he has acquired, that he has seen in the parameters. And right now I could enter all the pin names, I could type in the electrical type, but I prepared something which I will copy from the Excel sheet. So this is something you could do as well, typing down all data from an Excel sheet and pasting it in your component. And here we are, magically, I have a wonderful schematic symbol here. There's only one thing that has to be changed, and this is the designator. because it should look like U question mark, which will later on give us a nice designator. I will save this guy, go back for my component, and right now I only need an additional footprint. Here I will use the IPC compliant footprint wizard. There are quite some footprint shapes. I will stay with the SOIC. This guy is 8 pins only, so I have very few work in typing down only those values that I would find in my data sheet, and there's not too many different elements here. The 3-dimensional representation does not look too nice, so I tell Altium Designer to create a step model for this one. Going for next and taking all the values that are calculated automatically, even the board shape, IPC board shape, low, medium, or high density could be adjusted. I stay with medium density, and all those other things, I let him make those things automatically. And here we are with our wonderful footprint. I will do some changes here regarding the shape of pin 1, because I'd like to be able to recognize this later on in Kappa, because I don't want to have any silk screen pointing out where my pin number 1 is. Again, I will save the guy. Going back for the component, right now all information, all needed information is there. And again, I can save this to the server and Ben will get my first release of this device as well. And here we are, everything's done. In some seconds, Ben will be able to finish his schematic as all needed information has been made available to Concord Pro in Altium 365.
That's perfect. Thank you very much, Christian. So Christian's created a couple of parts for us there. We're going to Q5 and go back to Ben. And Ben is going to explain a little bit now about how he just goes and really simply just uses those parts in the schematic.
Yes, thank you, Christian. I really appreciate your help. So now that he's done those 2 parts, one is the 220 ohm dropping resistors for the RGB LED chip. So I'm going to find those, and I just do them by parametric search. Let's see, 220, did I do the right thing? 220 ohm. Oh, there it is, it's this, there was a Panasonic array somewhere. Christian, what was that part number? Oh, there it is. Panasonic, here we go. And that's the one he just built. So I'm going to use the nominal package to match the other parts and the size and the density of the design I'm working on. So I'll just place those. One of the things that's been in Altium Designer for a long time, which I really love, is this ability to just paste or place components in wires and they auto-insert themselves. It's one of my favorite things. So those are in there, and now the final device was that AES encryption, AES 132A. Let's see if we got that in there in the right package, and we do, and it's the SOIC chip that I'm working with a beautiful IPC compliant footprint there. And he's even magically put the pins in the order and spacing that I requested, which is fantastic. So all I have to do is wire up the power, the SPI bus. I'm going to throw a couple of no ERCs on those no connect pins. Not really necessary, but I'm a stickler for that kind of thing in a good looking schematic. And all I have to do now is annotate everything and throw it over into the PCB domain.
Great.
So I'll put some no ERCs here as well on these unused GPIOs. Annotation quietly. Save everything and update the PCB through the ECO. Now, something that I really, really love about proper component management is every time I move from I don't need the room, every time I move from schematic to PCB, I get green check marks. No footprint not found. I think that error is now reserved for the Altium website when you find a broken link.
So we're going to close that ECO out. Now we're all done. And Ben's going to move those components into the center of the board.
So there's all the parts, including the new ones.
So what we're going to do as a next step, okay, is we need an enclosure for this device.
We do.
So once he's actually moved all these parts over, we're going to then save this back up to the server using the same mechanism, right-clicking on the project, save the server. And we are going to invite another collaborator to come join us, who's now going to take this board and put an enclosure around it for us. Essentially going to take that board, get the enclosure, and they're going to make everything fit nicely for us. So on that note, could we cue Narek, please, our MCAD engineer. Hello, Narek, how are you doing?
Bonjour tout le monde. Ouais, comment ça se passe?
Excellent. So it's all over to you, Narek, please, now. If you could make us a lovely enclosure, that would be wonderful.
Now I will share my screen. I assume you see my screen.
Actually, Narek, 1 second. While you're doing that, just explain a little bit about the Co-Designer panel, because what Ben's going to do is actually push that over to you using the Co-Designer panel on his side. Okay?
Yeah. So, yeah, you know, well...
in fact, what I'm going to do quickly, Narek, I'm just going to switch back to Ben so he can actually show that process and make that a bit clearer. So
yes,
can we cue back to 5, please? Okay, so one thing I should say here, I did jump the gun a little bit, is we have this MCAD Co-Designer panel, okay? And this allows us to effectively take this model from the ECAD domain and push it into the MCAD domain. So this is the kind of connectivity bridge between both of these domains. And it's a very simple, straightforward panel to use. As you can see, Ben's just literally put a comment in there, he's hit the push button, and that's actually going to push all of that design over. And similarly, you'll see a bit later when we actually have to bring this back from the MCAD domain, it's also a very smooth, simple process of doing that. So let's cue back to Narek now on 6. He's got a similar Co-Designer panel on his side, which is a plugin with SolidWorks, which is a native plugin that has been developed by Altium. We support a couple of, 3 different MCAD platforms today, and they're growing. And Narek is going to take you through the process on the MCAD side, so you can see exactly how this kind of collaboration works. So over to you, Narek.
Okay, so I have this, the panel, so let me tell you this. Just a second, so I have to pull the design, which just have been pushed by Ben, and I'll save it. And let me tell you, while the board with the 3D components are on the way over the North Atlantic Ocean, I'd like to tell you that this bridging panel makes really life easier. Every single PCB produced in the world goes inside something, right? It is not only about the protection, but very often the commercial success in the marketplace of the final products depends crucially on package design. Yeah? I know electrical engineers are not really fascinating about this aspect, but we have to take this into account fairly early stage of design flow and keep it in sync throughout the whole process. So now I'm just waiting the components which are on the way. So now, even though I'm running in MCAD SolidWorks, so it is also available very same panel and other MCAD tools like Autodesk, PTC Creo. So we'll have the same feature, amazing feature, which really makes the collaboration seamless, effective and efficient, which is really eliminates all frustrations and really bridge these two worlds and close them together. So here we are. Okay, so I have a board. So what I do, I'm going to import the enclosure I've made for cher ami Ben. So now I'll put it here. And so you see, I have the dimensional problem. So I have to just first of all fix the the USB jack because it is very essential for board outline. And then I'll just, using very basic tool of SolidWorks, just set up mates. Okay. Just at least 3 points I need. Here we are. Okay, so this one I don't need anymore. And the last one, it looks already not so bad. So here I have, you know, a board shape which is not really very complex, but imagine when you have something really sophisticated, how it is difficult to deal with. So now let's see what we have here. Okay, so what I'm gonna do, I don't need really the default board shape, so I'm gonna change it with the profile which I've created based on the enclosure. So here, just it's a matter of going there and here we are. So now I see which is really fitting well, which is finally aligned, so it looks good. So in this very moment, I'll not consider, you know, the placement of the components, but look, it's done. I mean, now I've initiated the board shape, so I can go and pull the board.
Right,
Want
you
to
want to push?
Push the board, yeah, because it's already done to bend. So board outline done. Okay.
Where we go.
All the while, we keep in track the two products.
Awesome.
That looks fantastic, Narek.
Thank you very much, Narek. So Narek's actually got our enclosure. You see he's then taken that enclosure, he's fitted the PCB to it. He's not moved around any of the components because that's still in the ECAD engineer's domain, okay? So that's the way that we're going to work with this. But again, through that collaboration panel, we can move things backwards and forwards, pushing and pulling, and keeping everyone on the same page with actually what we're doing with it, okay? So thank you very much, Narek. We're going to switch back now. We're going to, Ben's going to actually then pull these changes back in. We're going to show how this works on the ECAD side when we actually want to pull this back from this domain. So, Ben, maybe you can just talk a little bit through how that panel works with receiving changes.
Yeah, so I automatically got a notification once he'd pushed his changes up into the system. And much like the ECO dialog, I get to preview these things before I apply them. So here I can see there's a 3D body that's going to come in. And that must be the enclosure. If I want to see that in 3D, of course, I can hit 3. And I can see where the enclosure is going to go when I import it, or when I synchronize from the MCAD domain. I can see the same with the board outline. And if any components had moved, I'd be able to preview that as well. So I'm going to go ahead and apply those changes, and now we haven't placed any of the parts yet or done any routing, but I have the right board shape and everything fits perfectly with that enclosure. So now I need some help routing and placing.
PCB designer, right?
So I'm going to save that to the server again.
So now what we're going to do is our third collaborator is we're going to have Antonio, who's going to come in. He's actually going to take this, and he's going to do the component placement. He's going to do all the routing and layout for us. So once Ben has saved this, again, same process, just pushing it back up. I'd like to introduce you to Antonio. Antonio, how you doing?
Buenas tardes a todo el mundo. Good evening.
Good evening. How you doing? You feel you'll be able to lay this board out for us?
Sure thing. Let me share my screen first. There you go. So I'm going to route this USB stick, and in order to speed up the whole process, I am going to use a couple of really neat features from Altium Designer. First, I'm going to place every component really fast with the help of a TXT file where the position of every component has already been defined. Then I will route the whole board using the auto route, and you will see how good the result is and how fast it is made, because instead of creating the rules that I need step by step, I will load the whole set of rules that I need from a set of rules that I normally use when I'm working with this kind of devices. And at the end, I will place a couple of polygons, set them up with the polygon manager, and show the final result in 3D thanks to the native 3D engine of Altium Designer. So let's get started. The first thing that I'm going to do is refresh the project, because I want to be sure that I am working with the latest version. So it will be checked now. You can see these clocks here. That means that the project is out of date. So I will update the whole project. And these will close the documents that are out of date and open the latest ones automatically. And 1, 2, 3, here we go. Everything here, Asnarek prepared it for me. I will go into the 2D mode, and first thing is hide the outline layer, because that is where the 3D body lives, and I don't want to mess with it. Then I will erase the old keep outline of the border of the PCB and move the origin to the bottom left corner of the USB connector, just to start placing the new outline, the keep out automatically, rate, and use the component placement from a TXT file. Voila, here you have it, Un segundo. It took a snap, and now I'm going to play a bit to make it prettier, the text.
Excellent. So what we're going to do is Antonio is going to continue on with that in the background. In the meantime, I'm going to ask Ben to actually just give us a quick overview of ActiveBomb. And the reason why we wanted to discuss this a bit today is because, you know, if you're designing a product and you can't get the parts, you can't build it, all right? So we've got some really nice features inside ActiveBomb. I'm going to let Ben give you a quick 2-minute overview of that while Antonio continues.
Yeah, and I can hardly do ActiveBomb justice in this tiny, short amount of time. There's so much power in this, and it just keeps getting better and better. One of the first things you'll notice, of course, all the parts are grouped. By default, you can separate them out if you want, but they're grouped by a common part number or common library component. And of course, the colors draw your attention to where there may be no problems with finding the part in volume production. These components all have supply chain solutions associated with them, except for this one, which gives me a red warning there. And these ones, I'm getting a warning that they're not recommended for new designs by the manufacturer. That may not be a problem in this case, because there's still quite a few of them in stock at my preferred vendor. But let's just say I need to add an alternative drop-in replacement. This is the crystal load capacitor, 18 puff, 50 volt C0G. I'm going to add a new part choice list to this one, just so that I mitigate that supply chain risk. And rather than searching based on hard manufacturing part number, I'm going to search generically. So 18 PF, 50 volt. If I could see my keyboard, I should have turned the lights on my keyboard there, but C0G 0402. And there's plenty of choices there. And this one actually yesterday was 6 cents a unit. It's 0.6 cents a unit, now it's 0.3. So I'm getting luckier and luckier. There's 3.4 million of them in supply chain, so I'm confident we can use that. I'm going to go ahead and add that. So now I have, it's actually a different manufacturer, different component, but equivalent for my design for all intents and purposes. And now I'm going to rate that as my favorite supply choice, and I get a green all clear. There's a list of bill of materials rules checks, and they're entirely configurable, and they always run in the background So if something changes in the supply chain, or I have a problem, or something goes out of stock, I'll know about it straight away. I don't have to do anything. It's automatically always running these rule checks. And the other cool thing is you can add your own custom solution. So if you're working for a company that stocks things, or you have your own inventory, you can also add that in there too.
I think one thing to also mention there is that we're constantly improving the data sources. And one thing you guys might be pleased to hear is that a little bit, well, very soon actually, we'll also have IHS data feeds in here for manufacturer lifecycle information. So we're continually evolving and improving all of that. So another nice big addition that's coming to ActiveBomb soon. All right, could we just cue back to Antonio? Let's see how he's getting on with our board at this point, eh? Wow, he's actually finished it completely. Amazing, look at that.
Yeah.
So we're all done. That's our enclosure. It's our fully routed board. And we are ready to go. So do you want to just send that back to us, Antonio? Or have you already done so? Looks like you've already done it.
I will send it to the server. Routing down. And there you go. It's all yours, Ben.
Antonio, thank you very much. That's great. Right, okay, let's cue back to Ben, which is 5.
Okay,
let's
so
take a look at that.
I'm going to go ahead and refresh version control for these documents. It's just waiting for the server here. And let's try this again. Refresh. Did I go to the right place, Leigh? Version control.
Yeah, it might be a second if he's still pushing.
This is the risk when you... there we go. And you see my status has changed now. So I'll go ahead and update I'll just update the whole project. It's easier.
That'll pull it all in.
And it reopens the board design. And there it is. I've got the latest version.
So we're all good.
Beautiful work, Antonio. Thank you very much.
Right. So, Ben, do you want to just head on over to the Chrome browser and let's take a look. Everything we've seen so far has been looking at it from the authoring tool perspective inside Altium Designer, but I just want to show you what's actually possible through the web browser today. Because if you're not authoring, but you just want to consume or actually collaborate in terms of markup, commenting, that kind of thing, you can do that actually all through the browser. So if we're on projects now, you're seeing a list of these projects as we saw before. You also see that 3D thumbnail has been kept updated as we've kind of evolved and the whole design and project. Got a preview down in the bottom as well. We're going to double click on that particular project to open it up. It's going to spawn a new tab. Works much like a Google Sheet does or something like that. And once this thing loads, you're going to be presented with an environment that's very similar to Altium Designer, so it's quite familiar. You have the navigator on the left-hand side, properties and comments panel on the right. So this is a schematic view, as we're seeing it. Again, you can pan around, select objects, all this kind of good stuff. So it's not just kind of like a screenshot. You can actually interact with it. Bennett, can you just click on the PCB doc on the left side? So we're actually going to load the PCB document here. And again, you've got full control of all the layers. You can turn them off. So you're only looking at what you want to look at. And again, we've got a full 3D rendering that works on here too. So we can click on that, come in and actually see the 3D rendering of the board.
And
so
that is
really
stupidly fast as well.
Really quick. Really, really quick. So we're just going to go back to 2D mode quickly because I want to also show you really briefly the commenting side of things here. So again, when you're collaborating, a lot of the time, the way that people are working today is you're sending emails, you're doing things and they're a bit outside of context. You might have a screenshot of something that you've drawn on or whatever. Now, this is really powerful because it's contextual commenting. It means that outside of the authoring tool, through the browser, you can come in, select an area, a component, and actually make a comment on it which gets attached to the actual design, as Ben has just done here. Now, what we can do is then move back to Altium Designer. We put this back into 2D mode. If we go to the comments panel, this comment will actually show up. So in the bottom right-hand side, Ben, you select the comments panel there. You'll see that that comment is there. So the really cool thing about this is that it all works in real time, and it means that if someone puts a comment onto a particular design, it's not going to be lost in an email inbox somewhere or in a document that no one's looking at. It's there, you can't miss it. So this contextual commenting, a really big thing that we've had some really good feedback on going forward. So that's pretty much it in terms of the project. I think within 45 minutes we got that done. We took you through everything from signing up for Concord Pro to getting your workspace provision, to doing schematic capture, to getting components created, to the MCAD co-design, to getting everything placed, everything routed. I mean, that was a lot to do, but we really wanted to show you the power of how this works, okay, going through that. There's one more point that I also wanted to share with regards to 365. I told you before this is really about connecting design, manufacture, and supply chain. So can we just cue 7, please? One of the capabilities that we have today now in 365 is to actually share what we call a manufacturing package. So this is a manufacturing package for that design. And what that means is that we can effectively wrap it all up. Instead of it just being a zip file that's in a Dropbox or something like that, we can actually send an email link to someone without inviting them into our design workspace, and they can access that. So that's what I'm going to do. I've got one of these emails with one of these links in. I'm going to click and open it in 365. And you get this kind of lovely graphical view of it. So instead of having this zip package where I'd have to unpack and go and find my Gerber viewer and all that kind of good stuff, everything's actually there already in the web. So we can come here. We've got all of our parameters that tell us about our bare board, how many parts we've got on it, all that stuff. We've got preview images of it, as you can see here. So it's very visually rich. And then on the left-hand side, I can click, say, fabrication. And what we've got here is a fully functional Gerber viewer inside the web. So this is not the design as it was in AD from AD kind of proprietary data. This is actually manufacturing output, it's actually Gerber. And we can control the visibility of that Gerber all from the bottom as well. Now the other thing that we can also do is click on assembly here. And again, we get a kind of 3D view of what we've just created. Now this has got the enclosure on it, but without the enclosure, you'll be able to see all the parts, you'll be able to see where everything is. And again, if you're going to manufacture, a lot of the times, people will have all the information they need to build your board, but they don't necessarily know what it's supposed to look like when it actually comes out that oven at the end of it and goes to first article inspection. So this is a really, really powerful thing, again, that's just going to really help improve the collaboration between people in design and people in manufacturing. And this is just one step. It's one step, and it's the one step along a very long journey, and we have some really, really good ideas and things that we want to do to further improve this. Too.
So wait, if I need to run down to the lab and I have an iPad in the lab and I'm testing something.
Yep, you can do that.
I don't need to take my whole rig down there.
You don't need to take your whole rig. So it's things like that. It's all of these use cases. If you're down in a lab, you wanted to cross-probe, you're a software engineer who's doing board bring-up and you need access to some schematic information. You no longer have to fire up your AD and get all of that. It's just in the browser and it's really easy to access. And there are untold number of use cases like this. So it really just opens this up in ways that we just haven't had before. I mean, really, really powerful. Okay, so on that note, what I'd like to do is I'd like to bring back on all of our collaborators today. We're going to wrap this up, okay? And I just want to say a big thank you to everyone who's helped contribute to making this a success. Thank you very much. A round of applause. That's great. Well, thank you very much for taking the time to enjoy that.
All right, that, ladies and gentlemen, is what 3,000 hours of practice looks like.
And it ran perfectly for like five.
Absolutely flawless.
Absolutely to clockwork, apart from that. But
and you know, look, that was absolutely real. None of that was contrived. None of that was fake. As a matter of fact, as we practiced it, at one point, one of the gentlemen was actually on the train.
Yes.
Going, I think, between our Karlsruhe office and Munich, and he did the practice from the train, and it absolutely worked.
So these guys were in Europe.
Yeah,
so
that was real.
That was all shot from Europe today.
That was absolutely real, and they were absolutely wearing those costumes. And look, here's what I will say, and this is why I've remained at Altium for 15 years, because we do this, right? I don't know of any other organization in any business, quite frankly, that would take the risk that we do in showing y'all and trying to perform something like this. And for me, I'm very proud of it. And so we've talked about motorcycles a little bit. I did a fair amount of motorcycle racing. And here in Southern California, it's desert racing. And I'm Mr. Second Place. I'm the fastest second place guy that ever existed. And there's a reason for that, is because I was very good at following the line of the guy in front of me. Because I didn't have to worry about what was around the next corner. I let him navigate the dust. And it's just easy to be a follower. I could get right on his tires absolutely fast, had all the horsepower I needed, equipment, no problem. Get right on his tire. I could even pass him for a little bit. But as soon as I passed him, I'd look over my shoulder, and he'd pass me right back. Just couldn't win. And Altium absolutely challenges that paradigm. We absolutely lead from the front, and that really takes a courage that I just don't see any other organization having. And when we talk about the problems that we've discussed with all you guys privately, personally, throughout the week, you know, Leigh was at the luncheon. We had people from the manufacturing industry, from the PCB, the engineering community. You know, what was the feedback you got, Leigh?
Just communication, you know, just people actually coming together. Things are getting more complex, design cycles are shortening, you know, just need to work closer together. And it's funny because we actually move further and further and deeper into silos all of the time. So that was the common theme that ran through that discussion, you know, working better together.
Yeah, and look, I've read a book I've recommended to many people. It's called Alone Together. And there's just absolutely no excuse in 2019 why we have to be that way, why we can't be virtually connected. I mean, what you saw just now was absolutely real. And what powered that was the cloud. And I don't believe that resisting it any further. Now, certainly, look, if you can't do it for various reasons, that's a different animal. If you want to purchase Concord Pro on premise, we absolutely offer that. But I believe what we've shown is the elegance and the convenience and the ease of what we can do with the cloud with 365. And with that, unless you have parting comments, Leigh, I think we can conclude the keynote.
That's it. I just want to thank everyone for your time and your patience today, and really hope that you know, you enjoyed that. We worked really hard at doing it, so you know, appreciate it. Thank you for your time.
Thank you very much.